One of the things that we can do is we can also kind of work some of these quadratic equations backwards. So instead of solving for the solutions, well, what if we can start with the solutions and work our way back to a quadratic function that had those as their specific solutions? So let's just work our way backwards and see what we can do. The solutions were these, so what does that mean? That means that x equals minus 5/3 and x equals 1/2. We got those as solutions because we understood that x plus 5/3 equals 0 and x minus 1/2 equals 0. Those were the quadratic's factors. So let's before we put that together, let's multiply this one by 3 because I just want to clean up the denominator. So let's multiply this one by a 3 to both sides. I don't know about you, I like working without fractions. So this becomes a 3x plus a 5 equals 0. And I'm going to multiply this other one by a 2 on both sides. And this becomes then a 2x minus 1 equals 0. I have my two factor sets. One factor is 3x plus 5. The other factor is 2x minus 1. Let's FOIL those together. First times first produces a 6x squared. Outer terms is a minus 3x. Inner terms is a plus a 10x. Last terms is a negative 5. And then group the like terms. So there you have it. There's a quadratic expression, and it's set that equals 0, the quadratic function whose solutions were negative 5/3 and 1/2. It's not the only expression that has those as solutions. Any multiple of this will also have those solutions. But regardless, this is an expression that has those as solutions. Don't believe me? Well, let's do it the other way around. Let's start with this. Let's start with 6x squared plus 7x minus 5 equals 0. And let's solve that. Let's figure out what are the x's to make that true. First of all, we see if we can factor it, because we always want to check factoring first. And the ones I want to try, let's try a 3x and a 2x. Then let's try what makes a negative 1 and all those things. Let's try a negative 1 and a positive 5. Does that match up? 5 times a negative 1 is a negative 5. 3 times a 2 is a 6. The outers and inners, so I have a negative 3x plus a 10x gives me a 7x. So those are the factors. We know for this to be true that either 3x plus 5 has to equal 0 or 2x minus 1 has to equal 0. Where are the x's that make that true? 3x equals a negative 5. X equals a negative 5/3. And over here, I have a 2x equals a 1. X equals 1/2. My solution set then is a negative 5/3, 1/2. Well, how about that? How about that? That's exactly what we got were the solutions. So when we're dealing with these, we can solve for the solutions, or we can start with the solutions and work our way back to an expression that the solutions came from. Two solutions, I have plus or minus 2√3 are my solutions. So what's one possible quadratic equation that those came from? Well, for this to be true, we know that x equals a negative 2√3 and x equals a positive 2√3. To create the factors those came from, this would be x plus 2√3 and equals 0. And this one is x minus 2√3 equals 0. Those are my factors. So I have x plus 2√3 times x minus 2√3. All of those equal 0. So multiply these two together. I notice it's the result of a difference of two squares. So this becomes x squared minus this term squared, which is 2√3 squared. And I can kind of clean that up a little bit. That's an x squared minus a 2 squared and a √3 squared 2 squared is a 4. Root 3 squared is a 3. So I have x squared minus 12 equals 0. And that's one possible equation or function that produced those two solutions. Again, why do I say that was only one of the possible ones? Well, imagine, if you will, that I took this equation, which is good, and I scaled it up. Maybe I multiplied this one, both sides, by maybe a 3. So then I would get an equivalent expression or equivalent equation of 3x squared minus 36. 3 times 0 equals 0. That's an equivalent quadratic equation of this one. It's just scaled up by a factor of 3. So if I solve this one, I would get those solutions as well. So let's look at one more way to do this, but we're going to do one with some complex solutions. So we have two solutions, plus or minus 5i. Tells me that one solution, x equals 5i, and x equals a negative 5i. X minus a 5i equals 0. Solve this one for 0. That's x plus a 5i equals 0. Those are my two factors. Let's multiply them together. X minus 5i times x plus a 5i equals 0. Again, I kind of recognize this as difference two squares, but let's FOIL it out just so we get a sense of what's going on. So I have to do a double distribution, which is what FOIL does. This term times that term, that times this one, that one. So I have to multiply 4 times. So first times first is x squared. Outers is a 5xi. Inners is a minus 5xi. And last times last is a negative 25. Negative 25i squared. Notice the middle terms cancel out. So I'm left with x squared. And then I have a minus 25i squared. What does that look like? That's an x squared minus a 25 times a negative 1, because I squared is a negative 1. Then I'm left with x squared plus 25 equals 0. All those were equal to 0. So one possible quadratic that I started with that produced these two complex solutions is x squared plus 25 equals 0. Again, that's one of many because I can scale that up by multiplying both sides by a constant. For example, 4x squared plus 100 equals 0. Both of those will produce the same roots because this one's the same equation just by a factor of 4. But that's the one that we're going to look at because that's the one that's simplified. That's the one that's in simplest form that will kind of complete our work on this one. So again, we can start with the equation and work our way towards a solution, or we can start with a solution and work our way towards an equation.